Welcome to the user dev meeting, everybody. So today our guest speaker is Joel Davidow. He's a Ceph operator from the National Solar Observatory, and he'll be presenting a feature request about tape as a storage class for object storage. So take it away, Joel. And I'll say if anybody has questions during Joel's presentation, feel free to say it in the chat, and we might make this session a bit more interactive this time around. So, and Joel is available to field the chat, and I will be as well. So, take it away.
Well, thanks for that introduction, Laura. Let me just start my screen share here. And as Laura was saying, if you have questions as we go, feel free to just pop them in the chat and we'll try to answer those as we go. Okay, hopefully everyone can see my screen now.
Yeah, looks perfect.
Okay, great. Okay, so as Laura mentioned, this is a feature request, basically to add a service that's backed by tape that would be analogous to AWS Glacier. So before I get into the request itself, I just want to give you a brief background on what the DCIS project is, so you have an idea of the context where this is coming from. So we'll start with the telescope. DCIS is an acronym for Daniel K. Inouye Solar Telescope. It's a 4-meter solar telescope on the island of Maui in Hawaii. It's the largest solar telescope ever constructed. It has a cutting-edge instrument suite. It gathers unprecedented data and images from the sun's surface to its lower atmosphere. It observes fundamental solar magnetic and plasma processes, and it provides scientists data to investigate a lot of things, including the structure and dynamics of magnetic fields, magnetic field interactions with the embedding plasma, transport of energy through the sun, as well as flares and coronal mass ejections. This is just a cutout illustration of what the telescope looks like. There's a person for scale down on the bottom. As you can see, this is a very large multi-story structure. Sunlight is collected in a main mirror here and then is reflected by a series of mirrors and sent down to the instrument lab, where another set of mirrors splits the sunlight out into beams that are picked up by a variety of instruments that actually create the data. That data is then transported and stored in the facility and then is transferred to the data center. The data center itself is located in Boulder, Colorado. It consists of application services running in a private cloud. We receive the data sent via Globus from the telescope into an S3 bucket in Ceph. We then ingest the received data that meets the requirements. That's kind of a quality control check right there, into another S3 bucket in Ceph and archive copy offsite to AWS Deep Glacier. We then programmatically calibrate the ingested data via pipelines and store that calibrated data in Ceph. And then we make the calibrated data available for search and download from Ceph via a data portal. We also provide a set of user tools to assist navigating and downloading large data sets. These data sets range roughly from several gigabytes to several tens of gigabytes. So data transfer to end users is potentially an issue. This is an early example of DCIS imaging. It's basically an image of sunspots on the sun from data that was taken in May of 2021 from one of the instruments on the summit. There are a number of different instruments, and some of the instruments, in fact, are still in the process of being installed. So still early days. This is an overview, vastly simplified overview of what I call the sunlight to science process. It's kind of from soup to nuts what happens. So starting on the left, there's that cutout of the telescope again. So the sunlight is captured by the telescope, is routed to the instruments, is split out into the instruments that they create the data. That data is then sent via Globus to the data center, where we ingest it, archive it, calibrate it, archive the calibrated data, and provide search of and access to that calibrated data. Scientists from around the world will then search that data via the portal and our user tools, and then they'll get the calibrated data that they're interested in, again, using Globus to transfer it from Ceph in the data center to some local endpoint that they have for data storage on their end. And then once they have that data, they'll do their science and publish their papers. So getting now more into the feature request itself, again, it's to add a service backed by tape that is analogous to AWS Glacier. So from our perspective, some of the key advantages and use cases for using tape with Ceph, some of the advantages are the potential to reduce storage cost, reduce space utilization, reduce power consumption, reduce cooling load. So most of those are data center constraints that we have, and also budgetary and personnel constraints. So potentially could help in a number of different areas. The main use cases we have in mind, the main first one is long-term archive. So this would be long-term storage of data sets that are characterized by infrequent access, large size. Like I mentioned, these could be several gigabytes, several tens of gigabytes, and acceptable availability for download in hours or days. So, we're serving up scientific data for science analysis. So we're not doing real-time financial transactions or, in a commercial situation where small amounts of latencies will be problematic. So that's a plus on our side. Long term, what does that mean? That probably means somewhere, definitely more than 10 years, possibly more than 30, maybe 40. There's a big question mark on how long the entire project will run into the future, but multiple decades is probably not out of the question. So during that time frame, tape lifespan becomes an issue. Of course, that depends on environmental conditions, the particular hardware, the use conditions. Maintenance of the entire tape infrastructure over that time frame is part of the challenge of all this. Another use case that we're considering potentially using tape with Ceph for is ransomware protection. Some additional use cases that we haven't really thought through completely, but are kind of on the drawing board as maybes, disaster recovery, and potentially backup and restore for some edge cases. This is a summary of current options for using tape with Ceph. This is just primarily based on me searching the internet. So this is not by any means intended to be a complete list. And my apologies to anyone out there who I've inadvertently missed and who is not on the list. I've organized the slide kind of by method of tape integration. So the first one's a third-party S3 API implementation. When this project was started, we looked at using SpectraLogic's Black Pearl in front of a tape library in conjunction with Ceph. But at the time, the S3 API didn't give all the functionality that we needed. So we just went with all disk. Another approach to integrating tape with Ceph could be using a third-party application. An example of that is SpectraLogic's Store Cycle, which they came out with more recently. And that sits in front of the Black Pearl unit, which sits in front of the tape library. That does address some of the issues that we had initially. It gives you an option of either leaving the object in the Ceph cluster or removing it from the Ceph cluster. And so it just exists on tape at that point. There are a couple of drawbacks from our use case perspective. One is it's a manual process. We're trying to fully automate as much as we can, ideally everything, but as much as we can in reality. We have a small team, and once the telescope gets into full operations, which means all the instruments are installed, they've all been brought up to speed, and we've run through using them a lot and figured out exactly what the kinks are and ironed out all the wrinkles, and we're kind of into the stage where we're doing full-time science observations. We're going to be generating a fair amount of data. So in order to keep up with the anticipated level of data production from the telescope with a very small team of people, we need to automate as much as possible. So unfortunately, if we went with store cycle, that would break that model. There'd be a big manual process in there. Another drawback is it's theoretically possible to integrate it into our workflows and application services. It still would be that manual process part, but it's theoretically doable. But the other barrier is the level of effort to do that. The system redesign would be really more than we could handle with the available capacity of our team. Another third-party application I've come across is from Nodium. I just found a marketing case study on the web, so I don't really know what the state of that product is. Haven't really found much more information than that one PDF case study, so I don't know a lot about that. And then finally, the last thing that I found or heard of is intercepting S3 API in Ceph, and there's a product called Solo Blue. Thomas Bennett and Martin Slaver presented this at Ceph-LaCon in 2023, and to my knowledge, that's the most direct attempt to integrate tape with Ceph, at least that I'm aware of. They're actively working on that, and it's a pretty cool project and very exciting. Not sure where that will end up in terms of the roadmap and how we might be able to use it on our end, but it is kind of at the top end of RGW as opposed to lower down, kind of in Rados. So that's what I found so far. Again, may not be complete, and apologies to anybody I inadvertently left off there. So what are the kind of things we'd like to see in this service that would provide Ceph tape storage? Before I go through these bullets, I just want to start by saying this is a deceptively simple slide. It's just a list of bullets. But in order to make these bullets real in an operational world, there's a lot of development work that would have to be done and some serious design challenges that would have to be tackled and overcome. So it looks like a simple slide, but it's, I think, a pretty significant level of effort. So having said that, we'll get back to the simple world. So the first feature that would be great to have is native integration. So that would basically mean that Ceph would manage the operations of the tape infrastructure needed for moving objects around. So like you do S3 lifecycle now, and it's basically transparent from like the RGW client perspective because Rados handles all that underneath the hood. So this would be similar. Rados would just magically handle it underneath the hood. And the Ceph command would include a category for tape so operators could interact with the system as needed. The second major category feature would be transparent media transitions. And this is kind of related to the native integration one. The first big ask would be to maintain RGW client's object name as an object transitions between types of storage. So I put that in there for two reasons. One is our inventory system assumes that the name of an object will never change. And one of the big challenges with using store cycle for us is that the object name will change. So in addition to all the mechanics of moving things in and out of the cluster, we would also have to have a way to keep changing our inventory. And that's easier said than done. It would also be great to automate a strategy to avoid a single point of failure and ensure integrity of data on tape. So, for example, we would not want to be in a position where we had one copy of an object on one tape at any one given time, because that's a single point of failure. So we have replica 3, or we're using erasure coding on our data pool, for data protection. So at the tape level, there needs to be some sort of analogy to that. How it would look, completely unknown at this point, but something along the lines of avoiding single points of failure for data protection. And then finally, programmatically manage S3 requests for objects stored on tape. Again, sounds simple, but you have to deal with long latencies there. I mean, you get requests for an object on tape. You have to find what tape it's on, where it's on the tape, load up the right tape, move the tape to the correct position, read the tape. All that takes clock time. And the latency on that GET request is going to be huge. So how do you deal with that? Unknown. Big question. Another bucket of service features for this service would be great to have would be programmatic migration to tape infrastructure. So again, this goes back to just maintaining the components of the tape system that will change over time. So migrating to new versions of tapes, new versions of tape libraries and their associated software, right? Tapes will age out, new versions of tapes will be introduced, new versions of tape libraries will be introduced. There'll be bug fixes and upgrades for robotic arms and the libraries and things along those lines. So all that's going to have to be changing under the hood somehow. Again, easier said than done. And then the last big bucket is the capability to air gap the service's hardware and software. And this is primarily to protect against ransomware attacks. So being on tape is in and of itself a step in the right direction, but if it's automated and it's online, it's still vulnerable. So the only way to really assure that is an air gap. Again, easier said than done, right? How do you air gap an automated system? Okay, not an easy question to answer. So this is an example of what a conceptual workflow to set up Ceph tape storage might look like. And basically, I took a very simple approach to this. I just took the current workflow to set something up and basically inserted tape stuff. So how it would actually work may not be this at all. This is just me throwing some mud on the wall, and I'm not a developer, so I'm not saying that this has any stickiness. It's just a shot in the dark. But based on the way things work now, you would create a pool that would use tape for storage using the Ceph OSD pool create command. Now the pgnum and protection attributes on there, it's unclear how that would be applied to tape storage, because that's a whole different animal, and how that would work in a tape world is one of those big unanswered questions. The second step would be to add a new storage class to a zone group using the Radios Gateway admin zone group placement command. Again, this is just the standard workflow now. And I've got an example adding storage class Glacier. And then step 3 would be configure a zone placement for the storage class, again, using the Radios Gateway admin zone placement command. And this is basically adding a data pool for Glacier. And then finally configuring the S3 lifecycle. So the examples I found how to do that now on the web are 2 or 3 years old and use S3 command with XML rules file, which seems like it will work. But it'd be great if the Ceph commands were expanded to include set, get, modify, deletes to handle S3 lifecycle management. And finally, this is what conceptual placement with Ceph tape storage might look like. Again, just me throwing mud. So this is kind of what the Radios Gateway admin zone placement get command returns. And then I just inserted a fake line for Glacier there with the data pool that we had added previously. Again, would it look like this? Maybe, maybe not. It depends on how things actually would be designed and developed and implemented. So that's basically brings us to the end of the presentation. Happy to field any questions.
Thank you, Joel. That was a great presentation. I know we have Matt Benjamin on the call from RGW, who has comment. Matt, do you want to speak? And we can also get comments from other people as well. But go ahead, Matt. It seems like you've got something.
Well, if you wanted to use an S3 lifecycle, I mean, there's a lot there. I don't think you come up with a lot of stuff there. I don't think you need to do an intrinsic change to the Ceph OST cluster, although someone could do that, put an HSM down there. If you want, if the goal is to do it with lifecycle and up in S3, you could just transition. You could essentially transition lifecycle transition stuff to the robot if it has an S3 interface. There's a couple of gaps there, but that's mostly some stuff that upstream RGW can do. It doesn't solve the problems of managing your tape automation, but that's a complex long-term IT management project with hardware integration unto itself.
Yeah, that's a whole nother animal. Yeah, that's an interesting idea. I'd like to maybe learn more about how that potentially could work.
I mean, intercepting S3 is also valid, but that implies putting the workflow into custom code there, as Solo did. But possibly you could just use a lifecycle.
Matthew Vernon commented, I think the cloud lifecycle options are only one way.
That's income. That's one of the gaps. But the intended direction is that you'd be able to read through. Probably Glacier APIs would also be possible, but I think depending on the rules you wanted to impose, we intend to make it possible to read through.
Makes sense.
Would that still require custom coding? The reason I ask is, again, we've got kind of a skeleton IT team. So I'm half of the infrastructure team, and I'm pretty much most of the Ceph team. So that's kind of where things stand.
Well, not custom coding. I mean that part, that part without custom, workflows and things. That stuff is going to be part of RGW Ceph object. There's lots of other things you could do, but that foundation is going to be wouldn't require custom coding, but it requires the read through to be finished, or Glacier APIs to alternative. But that certainly would be used by other things, right? So it's not custom, and it's not super large.
Yeah, that sounds very intriguing. Is there any? Do you have any rough estimate of when that might be available? I mean, that it may not be an easy question to answer. So I'm just curious if you have a ballpark time frame on a roadmap somewhere.
Sometime in the next 1 to 2 years.
That's fair.
Yeah. So I mean, there's I don't want to speak about working. It's not an imminently arriving thing, but there are people looking at it or working on parts of it, and there's also a bunch of these other constellation of work around very large, or around tape automation. I mean, so I don't want to step on any of those things. They have totally different goals. But providing some, we already have transparent life cycle tiering. There's a plan to implement to potentially implement intelligent tiering or a subset of it. That I don't think that applies here. I think for your use case it's more archival, but you might want a simpler workflow. It might be as easy to do. It might be very easy to and so right now when you lifecycle transition, there's an option to keep a stub object. Now that could impose issues itself. I mean, if you have a sufficiently large number of vnodes, essentially of object names, then you eventually, and the data set is, the size of the data in the namespace is infinite, is unbounded. Then you still run into issues with the size of bucket indexes and things like that. That's what the stub is. But those things would then be, the option to transparently read through those is something we plan to do. The alternative with Glacier would be when the Glacier APIs, it's not a lot of code. But the goal would be, from our side, it would be not to be touching the tape zone. Where building resilient long-term storage lives, and there are folks from the Rados side, involved. But I don't think Rados intends to build that into an intrinsic anytime on the roadmap. But Adam or someone could comment on that.
Yeah, it does architecturally, it does make sense to fork it at the S3 level rather than add something to the Rados level, just because it's much more in line with the S3 world already, and it's a completely different thing to try to add to the Rados world. It's kind of like creating another world in there.
Just a question. Can you guys hear me?
Yeah.
Yeah, thanks. Matt, how does it change things if the tape system has a POSIX interface? You can just put files in a directory and mark them to stage them in and out of tape.
It changes things because you'd need a different kind of backend for the lifecycle transition, but that's not inconceivable.
Like, doesn't latest Rados gateway code have an abstracted storage backend?
It does, but yes, but it hasn't yet been envisioned to make an abstracted lifecycle backend.
Okay.
That's not insane, but no one has done that. Right. So there's not an immediate advantage to abstraction there, but there is already abstraction in a sense, right? Because you already have the storage classes, and you can transition to between storage pools already, and then you can, and then we implemented a cloud backend for it that basically does S3 operations, like that are indeed one way, as was mentioned, but at the moment, but to have a storage class that talk to your preferred storage API is not crazy either. But we wouldn't be building on Zipper, for example, at this point. And no, that's the work that Solo did is a little bit like that. It builds a workflow engine into the RGW. That's something you could build with Zipper, but I'm not sure. I don't know. I'm not an expert on how that on why that design was chosen. Probably to implement sophisticated nearline or other logic.
Okay, so your preference is the tape system has an S3 interface itself.
Well, my preference for Joel is I think it's one of the most reusable designs, and it's a commercial off the shelf concept, right? There are S3 to tape. There are S3s. There are tape library units, automations that have S3. So and there's an ecosystem of these developing.
Yeah. Okay. Thanks.
Yeah, this is Vincent. Let me comment on this one. The tape library with S3 interface is going to become a more or less a standard going forward. So I think that that's pretty good assumptions.
Great conversation. Something I was thinking of after this call, so we'll have the recording where we've talked about these things. Would it be helpful, Matt and others, Joel, to create like a feature tracker ticket with this idea on here, just to track any kind of feature developments that go on? Would that be helpful to the project, do you think?
Well, there should definitely be, if there aren't already, a couple of trackers for the next roadmap steps for S3 lifecycle tiering, and maybe Glacier APIs. If those aren't exist, we can make those for sure.
yeah, I just think that'd be a great way to track since they're with these things, it can be like a large overhead seemingly, but breaking it down into steps and maybe achieving parts too is always um, a way to go, and we can do that through just tracking progress on um, like you said, one tracker or various trackers for upcoming milestones.
Yeah, that sounds good. I will say that having an S3 interface on a tape library is a step in the right direction, but then the question becomes, how does RGW, excuse me, how does RGW keep track of where things are, and how does it manage retrieval from that tape system? So I don't expect those. Those are just kind of design type questions. I don't expect answers to those right now.
Well, the idea of keeping the sub object and being able to read through it under some conditions or some policy is one of the simpler ideas and that we probably would implement. The interesting question for that would be if existing bucket size limits, it assumes we're going to continue that model assumes that S3 will keep the bucket indexes that know where everything is, and there's eventually you eventually reach a point where that's not tractable. Then you need some sort of API like Glacier. But then again, that's kind of a de facto standard also.
Very nice. Any other comments about any of the any points on Joel's presentation? I guess I had one comment. So this is again, uh, we would need to figure out implementation about certain parts first. But Matt and others, what do you think would go into testing various features of this, various milestones? Do you think we have uh, the testing capabilities for all different kinds of scenarios that we want to test?
Testing with an industrial scale tape automation system would require planning and resources that we don't currently have, but maybe people do if things came together. Institutions have those, individuals don't.
Yeah, just a thought. If there are anything lacking, just planning ahead of stuff we can do to improve, testing around these scenarios. Just a thought I had.
Just one last comment from me. I just want to say thanks for the opportunity to the idea and get some feedback and input on it. I definitely appreciate having the forum to bring it up in, and the eyes and attention from the Ceph developers just to run this by you guys. It's great. So thank you for that.
Thank you so much for being the speaker today, Joel. We really are very happy to have you. And yeah, I think just some action items should be, if we don't already have those, I will create just a general tracker ticket for this feature, and then Matt and others feel free to break that down into smaller bits. But I think that will be a good way just to track progress on this going forward, whether whether pieces of it are achieved or the whole thing. That'll just kind of keep us accountable. And then I also have this meeting recorded, so I always upload this stuff to our archive, which is linked on the Etherpad. So we'll also have record of some ideas we talked over, linked to the tracker ticket. So yeah, any last comments about this great topic? All right. Thank you so much, everybody, for attending, and Joel especially, and have a great rest of your days. Thanks, everyone.
Thanks again, everybody. Take care.